Everyone, and welcome to the second video on histograms. So in this video, we look at what a typical exam question normally looks like. So I've written here, sometimes we will be given a part of a histogram and an incomplete frequency table. And we will then have to work out the missing sections by comparing the given parts of the histogram to the table. And it's actually really quite simple, which you will see when we work through these two examples. So, first example says the table below provides information on the amount of money spent on takeaway food by students in their first year at university. Okay, and you notice here we are not given the fourth interval, the frequency for the fourth interval. But when we compare it to the histogram, we are given the bar. And we know that frequency density is equal to frequency divided by the class width. And we can work out the class width, but we know that the class width here is 150, but we don't have the frequency, and there is no scale on the frequency density axis. So, we've got two unknowns, so we cannot go and work that out. We need one unknown. So if we have three things, frequency density, frequency, and class width, we need two knowns and one unknown in order to go and work that out. So it's really quite simple. You notice you're given another bar there, 200 to 250, and you are given all the information on the table. So we know there we have the frequency, we've got the class width, we have the frequency, we have the class width, which means we can work out the frequency density, which means we are going to have a scale, and then we can work out the frequency here, and we can go and complete that histogram, the bars in the histogram, if that is what is required of us in the question. Okay, so let's go and do that. We said we're going to use the bar that we are given and the complete interval that we are given, and we are going to work that out. So there we go. Frequency density is frequency divided by the width. So the width here is 50. The frequency is 25. So I know that 25 divided by 50 is equal to 0.5. So we just rub that bit out. So this bar, 200 to 250, has got a height of 0.5. 0.5. And so therefore, we can now go and work out the scale. So if that's 0.5, well, then it makes sense. 0.1, 0.2, 0.3, 0.4, 0.5. Just rewrite that, 0.5. There we go. Okay, so we know now that this bar here has a height of 0.3, that height, so the frequency density is 0.3. So I can say that the frequency, which is x, divided by the class width 150 is equal to 0.3, which literally means that, well, if x, let me change the color, x divided by 150 is 0.3, then I know that 0.3 multiplied by 150 must give me x, which in this case is 45. So there we go. We have worked out that the missing frequency is 45. Whoopsie. The missing frequency is 45. Okay, so just to recap, you are always going to be given one bar and one interval that is complete, that you can compare in order to work out the scale on the vertical axis, on the frequency density axis, in order to work out the missing part in the table. Okay, let's do one more example. The table below shows the mass in grams of newborn hedgehogs in a hedgehog conservation unit. Use the given histogram to complete the table and the histogram. Okay, so we don't have 12 to 15, that's missing, which is, something is not right here, 12 to 15. Something is not right here, 12 to 15. Okay, in the second example, we are told that the table below shows the mass in grams of newborn hedgehogs in a hedgehog conservation unit. Use the given histogram to complete the table and the histogram. So in this case, they actually also want us to go and draw in the missing bars, which I can't do at the moment because I don't have a scale for the frequency density and I don't have the frequency density here. However, we know that we are going to just have a look, compare this 12 to 15. I'm missing the frequency, but I do have the bar. So I'm going to use, I can't use 10 to 12 because I don't have 10 to 12 there. So in this case, I'm going to use 8 to 10. 8 to 10 has got the frequency, and I can work out the class width. Remember, that's my width. Width is 2, frequency is there. So I'm just going to say 15 divided by 2 is 7.5. So I know that this here is 7.5. Now, just be very careful when you work this out. You shouldn't, if you're not certain what the scale is going to be on this axis or how many squares, see if you can work something else out. So let's go and have a look at this bar, which is 4 to 8. 4 to 8, width of 4, and it's got a frequency of 4, so 4 divided by 4 is equal to 1. So that's nicer. So now I know that goes up to 1, which means 1, 2, 3, 4, 5 little squares represents 1 unit increment. So that's got to be 2, that's got to be 3, that's got to be 4, got to be 5, got to be 6, 7, and 8. Okay, and that makes sense there. That matches up with 7.5 being right in the middle there. Right, so let's go and work out what's missing. Well, in the table, I now know that this bit, I need to work out the frequency here. I know this is a class width of 3, and I know that it's got to be x, my frequency, divided by 3, which gives me my frequency density of 3, right? If I go across here, there we go, that's 12 to 15. So that's got a height of 3, so the frequency density is the height, 3. So x divided by 3 is 3, which means x must be 9. Okay. So we've completed the table in terms of what was missing. Now we need to complete the rest of the histogram, which means that we'll need to work out the first bar. And the first bar we've got there, 4 to 8, sorry, I was just checking. Then we've got 8 to 10, we've got that bit there. We've got that. 10 to 12, we need to work that out. That's a height of 2. And 19 divided by 2 is 8.5. So 10 to 12 is going to go up to right in between. Because remember, that's going to be 9. So it's in between there, 10. And as I always say, try and use a ruler just to be extra accurate and precise when you sketch that in your exam. There we go. 12 to 15 we have. 15 to 30, that's a class width of 15. So 6 divided by 15 is 6 divided by 15. Yes, 6 over 15 is going to be 3/5, which is 0.6. So that's going to be 0.246 all the way up to there. Okay, 15 to 30. Yep, that's correct. Okay, there we go. And that was the second example of how you would solve a problem where you're missing bits of a table and you're missing bits of the histogram, but you have enough information to go and work out the missing parts. Hope that was useful. As always, if you have a question, give a shout, put a comment in the comments box. If this video is useful, please like and subscribe. I would really appreciate that. And if there's any improvements you'd like to see, also get in touch, let me know.